Okay, so we are going to define exponents. Exponents basically the number that is multiplied by itself. 4 raised to 3. That means 4 is multiplied 3 times by itself. 4 times 4 times 4. So 3 is called exponent. And 4 is a number that multiplied by itself 3 times. We can call 4 to the third power or 4 cube. So what's if it is 4 raised to 3 means 4 times 4 times 4. The number value is 64. Now let's define power of 10. Power of 10 is a number that results when 10 is raised to an exponential power. The power can be positive, then number is greater than 1. If power is negative, then number is less than 1. You can see here 1, which is 10, 1 times 10 raised to 0, which equals 1. 10 means 1 times 10 raised to 1 equals 10. 100 means 1 times 10 raised to 2, it's 100. 1 times 10 raised to 3, exponent 3, that means 1000. 1 times 10 raised to 6 means million. Same here, you can see 1 times 10 raised to negative 1, which is 0.1, less than 1. Okay. 1 times 10 raised to negative 2, which is 0.01. So you can see exponent negative 1, negative 2, negative 3, negative 6, which tells us number which is less than 1. If exponent 1, positive 2, positive 3, those positive numbers in exponents tells us number which is greater than 1. Now let's discuss about scientific notation. The numbers in science are very large and very small. To avoid confusion, we use scientific notation. So scientific notation, you can see d point dd times 10 raised to n. It's power of 10. Now d point dd is a number between 1 to 10. And that's how we define scientific notation. So step 1, place a decimal after first non-zero digit in a number followed by remaining significant digits. So first thing, we need to make decimal place between first non-zero digit because those number is between 1 to 10. And step 2, indicate how many places the decimal place is moved by power of 10. Remember, positive power of 10 indicates decimal move to the left. A negative power of 10 indicates the decimal moves to the right. Let's take an example. There are 268 about several like 22 zeros helium atoms in 1.00 liter of helium gas. Now we need to express this number in scientific notation. We consider decimal places here and we are moving those numbers this side between 2 and 6. So when we express this number 2.68, which is between 1 and 10, and we are moving decimal place this way, so our exponent is positive. We are moving this decimal place to left about 22 places. 1, 2, 3, 4, 5, 6, 7, so and so forth. You can see the decimal place move from 2 and 6. So it's about 22 places to left. So our exponent is 10 raised to 22 atoms. So we can express this number in scientific notation, which is 2.68 times 10 raised to 22 atoms. Now let's take another example. The typical length between a carbon and oxygen atom in a molecule of carbon dioxide which is 0.000000116 meter. Now we need to express this length in a scientific notation. Now this is a decimal point and we are moving this decimal point between these two ones, right? Between this 1 and 1, because what? We need this 1.16, that number is between 1 and 10. So we are moving to 1, 2, 3, 4, 5, 6 and 7 places to right. When we move this decimal place to right to the positive and it's 7 places, so our exponent is negative. So we get d.dd 1.16 times 10 raised to n, 10 raised to negative 7 meter. So the whole number we express in scientific notation this way. And a scientific calculator has an exponent key. You can see exp, most of the calculator has exp for expressing powers of 10. If your calculator reads 7.45 e minus 17, means you can write 7.45 times 10 raised to negative 17. To enter a number in your calculator, you type first 7.45, press exp, which is exponent, and then you can type the exponent followed by positive or negative key.